Alright, so we move on. Welcome back to my YouTube channel, Massa Tutorials. Please do all to subscribe. Alright, so we are still on Analytic Geometry and Calculus, Math 102. We are starting with an example. He said, question 1. Which of the points P, -1, -2, or Q, 8, 9, is closer to the point A, 3, 5? Again, which of the points P, -1, -2, or point Q, 8, 9, is closer to the point A, 3, 5? How can you solve this question? What they are asking you is which of the following points, that's point P and point Q, which of them is closer to this point A, 3, 5? So let's do a sketch, just a simple sketch. We have point A, which is what? 3, 5, which is the boss man, the master himself, right? So then point P, -1, -2, then point Q, we have it as 8, 9. So they are asking which of these points is closer to that. So now what do we have to do? We have to find for the distance from point A to what? Point P. It's the same distance from point P to what? Point A. So we have to find for what? The distance. Then also we have to find for what? The distance of A to Q, or from Q to A. Do you understand that? Then we'll compare the one which is what? Less than. So if you get the distance of AP to be 3, then here you get the distance of AQ to be, let's say, 2. Now, which of these is closer to this point A? It's what? 2. Is this Q? Because the distance is what? 2, and here the distance is what? 3. So we have 2 units, then we have what? 3 units. Again, you just do a rough sketch. We have point A, point P, point Q. Right. Now, you have to find for the distance from A to what? P. Then here too, you have to find for the distance from A to what? Q. Right. So if you find for the distance of AQ then AP, then you compare your answers. Which one is lesser? Right. So the answer which is lesser will give you the one that is closer towards A. So we assume that AP is 3, then AQ is 2. They are all 3 units, then what? 2 units respectively, right? So AQ we have 2 units, then AP we have 3 units. That's the distance. So now AQ is giving us what? 2 units. That means these 2 units is lesser than these 3 units. So that means this Q is more closer to what? Point A, rather than this P to be what? Closer to this A. Alright, so how best can we solve this? So we have to find, first of all, we have to find for what? The distance of AP. Right? You have to find for the distance of AP. Distance of AP. You can write it as this. So if any mathematician sees this, or if your lecturer sees this, that you have that, then AP, it means the magnitude of AP, or the modulus of AP, or the length of AP, or the distance of AP, right? Or you can also write it as D, bracket open, AP, which is the distance of these 2 points, AP. It's also accepted. So now you quote your formula, which is what? X2 minus x1 all squared plus y2 minus y1 all squared. So we are finding for the distance of AP. So we exclude this Q. We are not concentrating on that. So we have x1 here, y1, because that's the first value. So that's our x coordinate. So x1, then the second value, that's our y coordinates. x1, y1, then here x2, y2. Then we substitute. So the length of AP must be equal to square root of x2, which is what? -1. Then we have our minus, then x1, which is what? 3, all squared, plus y2, which is what? -2, minus y1, which is what? 5, all squared. So the length of AP must be equal to square root of -1 minus 3, which gives us what? -4, or what? Squared, plus -2 minus 5, which gives us what? -7, all squared. So we move us in. Let me bring my equal to here. So square root of -4 all squared. Watch carefully. -4 all squared. This squared is affecting negative and also affecting what? 4. But this, since this 2 is an even number, it takes the negative away, or it transposes the negative to be what? Positive. So I can get, or you can still write it as what? -4 times -4. This 2 is affecting negative and also affecting what? 4. Then plus 2, the same thing applies to that, so I'll get -7 times -7. So which means the length of AB must be equal to what? -4 times -4, which gives us what? 16. Then plus -7 times -7, which gives us what? 49. So still we have what? 16 plus 49. So I have 49 and 69 plus 6 gives what? 15. So we write 5, carry what? 1. 1 plus 4 is 5. 5 plus 1, which is 6. So I have my what? Square root of what? 65 units. Square root of 65 units. You can check square root of 65 in decimals. This one is a set. So length of AB in decimals, it is 8.06. So let's assume that to the nearest whole number, or to the nearest degree, which is what? 8.00 units. 8.00 units. So now we know that the length of AP is what? 8.00 units. 8.00 units. That's the length of AP. You can watch. Alright, so let's click. Then let's solve for AQ. 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 So AQ. So we have AQ, 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 right? So now we are finding for the distance from A to what? Q. So now this one is x1, y1, then here x2, y2. You can do it as x1, y1, x2, y2. You will still get the same answer. If and only if you solve it properly, you will get the same answer. So now, square root, we have x2. x2 is what? 8. Minus, minus is there. Minus x1, which is what? 3, all squared. Plus y2, which gives us 9. Minus y1, which gives us what? 5, all squared. So still square root of 8 minus 3, which is what? 5, then squared. Plus 9 minus 5, which gives us what? 4 squared. So I can say that 5 all squared, which is 5 times 5. But this time around, 5 is a positive value. Then plus 4 squared, which is what? 4 times 4. So we move us in. 5 times 5 gives us what? 25. Plus 4 times 4 gives us what? 16. So 25 plus 16. So we are adding 5 plus 6 is 11. So 1 carry 1. 1 plus 2, 3. 3 plus 1, 4. So we have the length of AQ, which is what? Square root of 41 units. So let's see. In decimals, we have, which is in decimals, we have 6.40. So to the nearest whole number, we have 6.00 units. 6.00 units. So the length of AQ gives us what? 6.00 units. So you can conclude, you can testify that the length of AP then the length of AQ, which one is smaller, is what? The length of what? AQ, which is 6.00 what? Units. So now you watch, then you conclude. So we can proceed, then we draw our conclusion here. We draw our conclusion. So we draw a conclusion. We can conclude. We conclude that. So you write. We conclude that. You conclude that since the distance of what? QA, or the distance between Q and A, is less than the distance between P and A, we say that Q is closer. Q is closer to A. So the question says, which of the points P or Q is closer to the point A? So now we can see that Q is closer towards point A. So we are done solving this question. Then now, so you can watch the conclusion very well. Alright, so we move on to our next example. So our next example, it reads as, what is the distance between points? So example 2. What is the distance? What is the distance between points -27 and 5, -3? So what is the distance between that? So our solution. We say that let point Z equals what? Or let Z be what? -27 and X be what? 5, -3. So we have that. Let Z be equal to, or let Z be this point. Let Z be -27 and X be what? 5, -3. So we are finding for the distance between Z and X. What will be the distance? So I have Z here -27, then X 5, -3. So what will be the distance? Watch very carefully. So now we move. What will be the distance between z and what? X. We are finding for the distance. We are using the distance formula, which is the distance of zx or the distance of xz. You see, the distance from Kumasi to Accra is the same distance from Accra to Kumasi. Nothing changes. Alright, so we move as in, we quote our formula, which is what? X2 minus x1 all squared plus y2 minus y1 all squared. So the distance of zx must be equal to, you denote here to be x1, y1, then here to be x2, y2. So x2 we have what? 5 minus x1, which is what? Negative 2. So I have my negative 2. All what? Squared. Then plus y2, which is what? Negative 3. Then minus my y1, which is what? Positive 7. All squared. So the length of zx must be equal to square root of that. So 5 minus this negative 2, I have what? 5 plus 2 all squared. Then plus what? Negative 3 minus 7 all squared. So the length of zx must be equal to 5 plus 7, which is what? 7 all squared. 5 plus 2 is 7 all squared, plus negative 3 minus 7, which gives us what? Negative 10 all squared. Right. So I have the length of zx, which must be equal to the square root of 7 squared, which gives 7 times 7. Then plus, here I'll get minus 10 times minus 10. So we still move as in 7 times 7, which gives what? 49. Then plus 10 times 10, which is negative 10 times negative 10, which gives 100. So the length of zx must be equal to what? 49 plus 100, which is what? 49. So we have 49 what? Units. You can punch your calculator square root of 49 units, which is a set. So we can leave it in decimals, which is 12.206 units. So to the nearest degree, which is 12.00 units. That's it. Very, very simple. Very, very simple. Alright, so that's our second example. Let's see our third example. So our third example, then I'll give you 3 or 4 examples to go and try on your own. Our third example, they said, find the length of AB to the nearest hundredth. So point A, which is 2,5, then point B, we have negative 3. Mind you can get fraction 2 as your point, so don't forget, you can get fraction, so please be conversant with your fraction scales, right? If you get addition of fractions, they have the same denominators. What do? You just add the numerators, because it's a light fraction, different denominators. That's what's on light fraction. So we just find the LCM, then we move through, right? So you have to take notes. When you get a mixed fraction 2 or a mixed number, you know how you can solve that. You just change it to what's improper fraction by multiplying the denominator or the divisor by the whole number. Then the result you get, you add it back to the numerator. Then you get what? Your improper fraction. Then you work it out. I believe you understand what is going on here. Alright, so find the length of AB to the nearest hundredth. To the nearest hundredth means we are talking of what? Decimal places. This one, TH is here. So we are talking of what? Decimal places, which is what? A 2 decimal place. 2 decimal places here. So find the length of AB to the nearest hundredth, which is 2 decimal place. So solution. How do we find for the length of AB? The length of AB must be equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So the length of AB must be equal to, now you have to denote your x1, y1, then your x2, y2. You have to take note of that too. So x1, y1, x2, y2. So x2, which is what? -3 minus x1, which is 2, then squared, plus y2, which is 3, minus y1, which is 5, all squared. So the length of AB, which is equal to square root of -3 minus 2, which is -5, all squared, plus 3 minus 5, which is -2 squared. So I have the length of AB, which is equal to -5 all squared, which gives us what? -5 times -5, right? Because the 2 is affecting the negative. Then plus -2 all squared, which is -2 times -2. So I have the length of AB, which must be equal to -5 times -5, which is what? 25. Then plus -2 times -2, which is what? Positive what? 4. So the length of AB, which must be equal to what? Square root of 25 plus 4, which is what? 29 units. But this time around, you have to leave it to what? Decimal places. You have to leave your answer in decimal places. Then you round it to the nearest hundredth. So square root of 29, which gives us 5.385,164, then it continues. So now we have the first decimal place, 1 dp, then we have the second decimal place, which falls under what? 8. So you check the next number. The next number is 5 or more. So we add 1 to this 8. So making what? 9. So our answer will be what? The length of AB must be equal to 5.39 units. So therefore, the length of AB equals what? 5.39 units to the nearest what? Hundredth. That's to the nearest hundredth, the length of AB is what? 5.39 units. So that's our third example. All right. Let's move on to our next example. Let me see whether I can solve one last example, then I give you more to go and try on your own. Please kindly watch the video so that the time you come to the school or the time you open for the second semester, you'll be okay or you'll be conversant with what you are coming to do under this course, Math 102, Analytic Geometry and Calculus. Alright, so my last question I'm solving here is this example, question 4. They said determine whether the points -8, 1, -2, 9, and 10, 0 form the vertices of a right triangle, or of a right angled triangle. So let me put it in the form that of a right angle, then we have that triangle. So they said determine whether. Do you understand that? Here is whether. Determine whether. So you can get your answer being not equal to what? A right angle triangle. It is correct. And also you can get your answer to be what? A right angled what? Triangle. But if the question falls in this way, as in show that the point form the vertices of a right angle triangle, my friend, that one you have no say to show that this point form that. So when you conclude and you are telling us that they don't form, then you are wrong. They said show that, so you have to show that. I believe you are getting it. But if the question is put in this way, that determine whether the points form the vertices of a right angled triangle, then you have to determine whether it is yes or no answer, not maybe. Yes or no. Just prove to us yes or no. I believe you are getting that correct. Alright. So now, solution. Now for right angled triangle, we'll be using Pythagorean triples. I believe you remember Pythagorean triples. It's a set of 3 integers, right? It's a set of 3 integers which obeys the Pythagoras theorem. So 3 integers. So you can list the 3 integers, this one. Then you check whether these 3 integers obeys what? The Pythagoras what? Theorem. So it's a set of 3 integers which obeys what? The Pythagoras what? Theorem. So now, if you have 3 integers as in this, 3, 5, and 7, and you know what an integer is? An integer which has the symbol z. So an integer is that. So that's an integer. They are what? Negative natural numbers and what? Positive natural numbers, including 0. Negative natural numbers and positive natural numbers, including what? 0. That's an integer, a perfect integer. Right? The definition for a perfect integer. So you cannot tell me that half or 0.5 is an integer. Right? So integers are positive and negative natural numbers, including 0. So now here, Pythagorean triples. There are only 3 integers. 3. Triples means what? 3. Then Pythagorean. Right? Pythagorean triples. That's what I can say, right? So Pythagorean triples is a set of 3 integers that obeys the Pythagoras theorem. And you know what a Pythagoras theorem states that? It states that what? The square on the hypotenuse must be equal to what? The sum of what? Of the squares of that length on the other 2 what? Sides. So this one must obey the Pythagoras theorem. So if this is obeying the Pythagoras theorem, then we have to first check. Now, the largest number or the greatest number is the hypotenuse in this set. The largest number or the greatest number in this set is the hypotenuse. So you take the hypotenuse, which is 7. Then you square that, which must be equal to what? The 2 sides are 3, then 5. Because addition is commutative, you can start with either 5 or 3. So 5 squared plus 3 squared. So 7 squared equals 5 squared, which is what? 5 times 5, and it gives 25. Plus 3 squared, 3 times 3, and it gives 9. 7 squared, which is 49, which is equal to, let's see, 25 plus 9. 25 plus 9. 9 plus 5. 9 plus 5 is 40. You carry 1, then you get 34. So I have 34 here. Now you cannot tell me that 49 is equal to 34. is not equal. So then that means this is not what? A Pythagorean triple. It's not a Pythagorean what? Triple. Why is it not a Pythagorean triple? Because it does not obey the Pythagoras theorem. So if it doesn't obey the Pythagoras theorem, then we disqualify this set as what? A Pythagorean what? Triple. So that's what we are saying here. So if you want to determine whether the points form the vertices of a right angle triangle, you have to first take note of this, because the right angle triangle obeys, or it follows what? The Pythagoras what? Theorem. Alright, so let's see how best we can solve this question here. Let's see how best we can solve this question. How best we can solve this question here. So now, you can sketch. You have to sketch so that you know what you are doing, right? Sketch. With coordinate geometry, you sketch so that you know what you are doing. You are sure of what you are doing. So now here, we can say that let point A be what? Negative 8, 1. Then point B be what? Negative 2, 9. Then point C be what? 10, what? 0. So point A, I have my point A, which is what? Negative 8, 1. Point B, which is what? Negative 2, 9. Then point C, which is 10, 0. So we have it as that. Can you watch it very carefully? Alright, so if you are moving on, then it means that we have to find for what? The distance. The distance of each side. So we have to find for the distance of AB, the distance of AC, the distance of what? BC, right? So you have to find for the distance of each side. So finding for the distance of each side, we have the length of what? AB, which must be equal to what? Square root of what? x2 minus x1 all squared plus what? y2 minus y1 all squared. So the length of AB must be equal to, we have x1, y1, x2, y2. So x2 is negative 2 minus x1, which is what? Negative 8. So when it comes, you get positive 8 squared. Plus y2, which is 9, minus y1, which is 1, all squared. So the length of AB, which must be equal to what? Square root of negative 2 plus 8 is the same thing as 8 minus 2. And 8 minus 2, we get what? 6. So 6 all squared. Then plus 9 minus 2, which gives us 8 all squared. So now you can punch your calculator, then you proceed from there. Very simple. So 6 squared gives 36 plus 8 squared, which gives us what? 64. So that's 6 plus what? 64, which is what? 10. Which is 10 here. So we have 10 units here. 10 units here. Then now, let's proceed finding for the length of BC. The same thing. We've quoted the formula there. So square root of, we can denote here as x2, y2, then here x1, y1. It's the same process. So now, x2 is what? 9 minus x1, which is what? 10, all what? Squared, plus we have our y2 which is what? 9, minus our y1 which is what? 0, all squared. So the length of BC, which is what? 9 minus 10 all squared. 9 minus 10, which is minus 1 all squared, plus 9 minus 0, which is 9 all what? Squared. So the length of BC must be equal to what? We have negative 1 all squared, which gives what? 1. Which gives 1, plus 9 squared, which gives what? 81. So we have square root of what? 82 what? Units. Square root of 82 units. Square root of 82 units. So we have this. The length of BC, square root of x2. x2, which is, oh, we made a mistake. Let's verify that sharp. So bracket open, x2, which is negative 2, minus x1, which is 10, right? Okay, then plus y2, which is what? 9, minus y1, y1 which is what? 0 all squared. So we have negative 2 minus 10. Negative 2 minus 10 which gives us negative 12 all what? Squared. Plus 9 minus 0 which is what? 9 all squared. So here we have negative 2 all squared which is negative 12 times negative 12. Negative 12 all squared. So I'll get what? 144 plus here I'll get 81. So 144, square root of 144 plus 81, which is what? 15. So the length of BC is 15 units, not 80. Square root of 82 units there. That's wrong. That's wrong. So we have that. So we have here to be 10, here to be 15. Then let's see the length of AC. The length of AC. The length of AC, square root of that. So if here is x1, y1, here is also what? x1, y1. So we can change one of them to be x2, y2. So now, x2, which is what? 10, minus x1, which is what? Negative 8. So I'll get plus 8 squared. Then plus y2. y2 is 0. Then minus y1, which is what? 1 all squared. Right. So the length of AC must be equal to what? We have 10 plus 8, which is 18 all squared, then plus negative 1 all squared. So 18 all squared plus we have 5 root 13 units. 5 root 13 units. Check that very well. Let's see that again. The length of AC. The length of AC, square root of x2. We know our x2 to be 10. Then minus x1, which is negative 8. So it will be positive 8 all squared. Then plus, we have y2. y2 is 0. Minus y1, which is 1 all squared. So here I'll get 18 squared. Then plus that. So the answer is 5 root 13 units. So here is 5 root 13. 5 root 13. 5 root 13. So please watch it very carefully. So now we are proceeding. Now they said we should verify or determine whether the points that form the vertices of a right-angled triangle. So now let's see. How can we determine? Now you know the distance from A to B, then B to C, then also from A to C. Now we have to verify using the Pythagoras Theorem whether they follow what the Pythagorean or their set of Pythagorean triples, or this distance units, they are right-angled triangle, or they obey the Pythagoras Theorem. So if they obey the Pythagoras Theorem, then you have to use Pythagoras Theorem to work for that. So let's see. You have to use Pythagoras Theorem to work for that. Using Pythagoras Theorem to work for that. Then we have the length of AB to be what? The hypotenuse. So the length of AB all squared, which must be equal to what? The length of what? BC all squared, then plus the length of what? AC all what? Squared. So the length of AB all squared, which is 10 squared, equals the length of BC, which is what? 15 squared, plus the length of AC, which is what? Square root of 5 square root of 13 all squared. So 10 squared is what? 100, which is 10 times 10 equals 15 times 15, which gives 225. Then plus what we are doing, we can see that it won't be equal. It will never be equal. It will never be equal. And you know that 5 square root of 13 all squared, these two affect 5. So we get 5 squared, then times square root of 13 all squared. So this one will be 5 times 5, which is 25, times this one takes off. So I'll get 13, right? So 25 times 13, which gives what? 325. Now, let's see. 100 is equal to 225 plus 325, which is 425. So here 425. So we can see that this is not equal to 425. 100 is not equal to 425. So it means that we can conclude that this point does not form the vertices of a right-angled triangle. This point does not form the vertices of a right-angled triangle. So that's the conclusion. So watch it very carefully. Alright, so I've solved 4 examples, 4 serious examples with you. 4 serious examples with you. The first example I solved is what you go and do in school. So take note. Maybe if they change it, it's fine. But if they don't change it, they will bring the same thing. So please watch and understand every procedure we do here. Right. Okay. So now you try these examples. That's home link. Home link. You try these examples. Home link. Home link. Home link. So home link. Home link. Which is assignment, right? So we have question 1. It says that what? The triangle ABC. The triangle ABC has vertices at the points A15, then we have B 4 leg 1 and C leg 2 leg 4. Full stop. I show that triangle ABC is a right angled triangle. Then I find the area of triangle ABC. You have to find for the area of triangle ABC. Then question 2. Show that the triangle whose vertices are 1, 1, 3, 2, and 2, -1 is isosceles. Then the last question. A, B, and C are the points 3, 5, 7, 2, and 3, -1 respectively. What type of triangle is triangle ABC? All right, so that's the question for you. So they are very, very simple. They are very, very simple questions. That's home link. Alright, we will end our tutorials here. Massa tutorials. Please do all to subscribe to Massa tutorials. Click on the like button, then you subscribe. then you click on all notifications. So when you click on the subscribe button, then you click on all, the bell there, all, so that you get all my YouTube videos. Alright, thanks for watching, then thanks for subscribing. Master tutorials made easy. Thank you very much. I appreciate. Have a nice day. Bye bye.